Hi everyone, welcome to this video from Grimsby College. I'm Joel Broddle, and in this video we're going to give you a basic introduction into TIG welding. TIG stands for Tungsten Inert Gas Welding, and you may have seen it as GTAW, so Gas Tungsten Arc Welding. The difference between this one and MMA, the main difference, this uses a gas. Normally it's an argon, but helium can be used as well, and it protects it from contaminants in the air. It started in the 1940s and was first used in the UK around about 1952. It produces high quality welds and was first used for welding aluminium, titanium and manganese alloys. It produces high quality welds, like I said, on aluminium, and we have an example of some aluminium welding here. When we're welding with aluminium, we'll use alternating current, but for this introduction, we're going to be using DC. So, on the welding set itself, slightly more complicated than MMA. We've got a Lincoln Electric Invertec V270 machine. On the machine, our return lead will be plugged into the positive. Then we have our TIG torch. Gas can go in. The HF, and then the actual torch itself. Twist to lock it in place. This set can do scratch start, HF start, and lift TIG. We are going to be using the high frequency, and all the high frequency is, it just helps you to initiate the arc. On the set itself, we can have pulse, we can have a slope in, slope out, we can have post gas to help protect the weld, and we can also have 4-step and 2-step. Now 4-step, you press the button, the machine will continue to go. You press it and it will slope out and stop. 2-step gives you a lot more control. You can keep your finger on the button and let go of the button to slope it out as well. All depends on what kind of weld you're looking for and what sort of defects you're trying to eradicate. On the head of the torch, we've got our button, which initiates the HF. We have the TIG torch head. Some of these are flexi head to help you get the correct angle. Some are fixed in position. On the back, you'll see we've got a back cap. What the back cap does, it tightens the collet and keeps your tungsten in place. Different sort of back cap there, if you're in a very small, awkward position. We have a 2.4 collet, as we're using a 2.4 tungsten. We have a collet body, or I've heard it be called a gas diffuser. And we have the ceramic. Now, currently on this one, we have a size 7 ceramic on there. You can get them all different shapes and sizes. Again, all depends on what sort of weld you're doing, what position you're in, and what kind of weld you're looking for. But a few examples here. There's a size 4, a size 6, so you see the diameter of it slightly smaller, and a very small one for our scratch start sets of a size 5. So I've mentioned the tungsten already. As you'll see on these tungstens, they are grey tipped. They are seriated 2.4 tungstens. We use seriated as they're a multi-purpose tungsten, good for a range of materials. I'm going to head over now to the tungsten grinder and show you how we put a nice sharp point on them. So this is our tungsten grinder, and this is the pen that's going to help me sharpen the tungsten. So tungsten slots into the pen, and we have the depth set as we're giving it a tighten, and this sets our depth to the end of the tungsten. To get this machine going, foot on the pedal, and press the green button to start the machine going. So this now has given us a really, really sharp tungsten, and this helps to direct the arc exactly where we want it. The idea with TIG welding is that this stays sharp all the time. I'm now going to take the tungsten out. Head back over to the bench to start the weld. My tungsten's now in my torch with a little bit of a stick out, nice and tight with the back cap. I've got my slightly different PP on this time. These gloves for TIG welding give you a little bit more dexterity. I've also got 2.4mm PZ6500 wire, and this is cut in half as to how it comes from the manufacturer. As you hopefully saw, press the button, it initiated the arc. I've only done a small little bit of weld, and I pressed the button again, and it sloped out very quickly to complete the weld. I'll head back over to the main bench and talk through a few main defects that we can get with TIG. So I'm now going to talk you through a few defects that are commonly found with TIG welding. The first one is cold lap. So on this weld here, you'll see that the weld actually hasn't quite melted into the parent metal on the bottom. The next one to look at is some undercut. So numerous reasons for undercut. It could be that your amperage was too high, that the scale on the plate was too much with it being low carbon steel, or you just haven't put enough filler wire in. And the main one with TIG is when you lose your gas coverage. So it could be that you're welding outside and the wind's taking it away. You've not got enough coming through the ceramic to coat your weld, and it's called porosity. And it will look like if you snapped an aero bar in half, all those bubbles, that's called porosity. That brings an end to this introduction to TIG welding. Thank you for listening.